So welcome you all to the last lesson of this section. So in this lesson, we are going to study about the classification of vibration on the basis of degree of freedom. That is on the basis of degree of freedom. So the minimum number of independent coordinates which are required to specify the motion the motion is motion of the system is known as degree of freedom. So in general degree of freedom is equal to number of independent displacement that are displacements that are possible and this number varies from and this number varies from 0 to infinity. So let's see some examples of vibrations and how to calculate degree of freedom. So first of all, we can classify the vibrations in three types. First one is single degree of freedom. Second one is multi degree of freedom, and third one is infinite degree of freedom. Now let's see some examples. Okay, so let's see some examples. So this one is the first figure here. So this is the first figure. So this is the K1 spring constant and mass is m1 here, and we are going to, like, suppose you have to find out the degree of freedom for this system. So just displace this mass by x1 here. So we know that the degree of freedom is the minimum number of independent displacements that are possible. So here only one displacement is possible here in for this system. So we can say that the degree of freedom for this system is equal to 1. Now let's see another case. So this is mass m1 and it has spring constant k1, and to this mass there is another spring attached which is attached to the mass m2, and the spring constant for second spring is k2. So the possible number of displacements for this case is, so this can be displaced by x1 and this can be also displaced by x2. So there are two number of minimum displacements which can occur in this system. So we can say the degree of freedom for this system is equal to 2. Now moving to the some more examples. Let me erase this thing. So for this system, just consider one more system here. Mass m1 here, spring constant k1, mass m2 here, spring constant k2, mass m3, spring constant k3. So for this system there are three displacements possible, that is x1, x2 and x3. So we can say for this system the degree of freedom is equal to 3. Now we can also say that the degree of freedom is equal to number of natural frequencies. Now let's see another example. Let me erase this thing. Okay, now we are done here. Now suppose so there is a string here which is attached to some circular mass m here, and we are going to give it some angular displacement theta. So there is only one possible displacement for this system. So we can say for this system degree of freedom is equal to 1. Now moving to the next example. Okay, so let's consider another example based on this example. So consider the string system. First mass is here m1 and it is displaced from its initial position by theta 1 angle, and there is another string attached to this system to m1. So which is m2, and it is displaced from its initial position by theta 2 angle. So for this system we have total number of two independent displacements which are angular in nature. So we can say for this system, degree of freedom is equal to 2. Now let's see one more example, few more examples. Okay. Now consider there are two trolleys attached by one spring. So there are two trolleys. So trolley 1 has mass m1 and trolley second has mass m2, and they both are connected by a spring here. So the trolley, and it has spring constant k. So the trolley m1 can be displaced by x1 distance, and trolley m2 can be displaced by x2 distance. So we can say for this given system, the degree of freedom is equal to 2. Now just consider, suppose, okay, let me raise this thing first. Now suppose this mass m1 is attached to some external thing here, which has the spring constant k. Suppose it is spring constant k, and we are going to replace this spring by a rigid body mass. 1 minute. So instead of a spring, now we are going to insert some rigid rod. Rigid rod is there. So this is the rigid rod. So in this case, the mass m1 will move by, so the mass m1 will move by distance x, and mass m2 will be also move by distance x, because to do attachment of rigid rod. So for this case, we can say for this system, degree of freedom is equal to 1. Now see one more last example of pulley system, of the pulley system. So just consider any pulley here. String is here and attached to this point. And this end has spring and it has mass m. So when this mass moves down, then the pulley rotates by theta angle, and it has, this spring has spring constant k, and it will move by x distance. So we know that x can be given by the formula x equal to r theta. So if theta rotates, then it will move by distance x, which is equal to x equal to r theta. So this is the relation between x and theta. So we can say for this system, the degree of freedom is equal to 1. So this marks the end of the section 1. And in section 2, we will learn about system parameters such as inertia, restoration, and damping effect. So now it's time to wind up the topic. Thank you.